So hello guys, welcome back to the channel. So today we will solve the next day of the problem, that is the smallest subsequence of distinct vectors. So what the problem is stating to us? Problem is stating, I will tell you in my words, you can read the problem statement 2, or the statement is also too small. So let's suppose in question we have given a string s equals to b c a b c. So this string is always consist of small letter characters, and we have to find lexicographically smallest subsequence that contain every unique character of that string we have to find lexicographically smallest subsequence. I hope you all know about subsequence. Subsequence is a type of, we can say, segment or subsegment of an array or string, in which we can select a character, and the next character of that subsegment should be after the previous character. We can skip any number of characters, like if we have a b c d e, so we have as a subsequence, first if we would select this character, then either we would select this or this or this, or after this we can select this, after that we can select this. But if we select this, then we are not able to select this or this. So after choose a particular element, we have to select the next element for the subsequence, and we can skip any element in between. So that is a subsequence. Now what is the lexicographically smallest subsequence? Basically, small lexicographically is something that we can say something like dictionary. If we have a b c, basically to calculate lexicographically smallest or something related to lexicography in characters, we are maintaining like c means the character which is coming after a particular character in English dictionary would be greater than the previous character. Like b would be greater than a, c would be greater than b, and b would be smaller than c. So this we are following in the lexicographically order. Okay, so now what is the lexicographically smallest? How we can do visualize that? So if we have a b c d e f, okay, so this is a string, and now if we start another string, or we are comparing this string with another string and try to find which one is the lexicographically smallest, then what we have, if we have this character greater like b, okay, so now onwards we have any character, that doesn't matter, but if we would check the first different character in two string, okay, and what one is lesser than the other one, that string contain the lesser one would be the lexicographically smallest string. Okay, likewise we have a b c d e f. If the another string is a b e, so here you can see these two are same and this is different. So what is the smaller one? This is the smaller one, so this is the lexicographically smallest as compared to this. Okay, So in this question, what we have to find? We have to find lexicographically smallest subsequence that contain every unique character of that string. That means if we talk about this string, so what are the unique character in this string? They are A, B and C. So we have to find a subsequence which contain all these letters, and that subsequence should be lexicographically smallest. So what we can choose, if we choose B, okay, or then we would choose after that C, or then A, then we would have all the three characters. But if we choose A, B and C, then here A B C would be less than B C A, okay, because first mismatch character here, and this is less than this, so this A B C is the less than lexicographically smallest subsequence. Okay, so this is our problem statement. Now let's think what we can do. Now I think problem statement would be more clear with this explanation. Yeah, I have tell you every bit of the problem what we have. So now let me clear all of these things and tell you the solution part. Okay, so let's suppose how can we do that. So I will not jump directly into the solution. I will tell you how we can approach these type of problems, in what direction we have to think. So here what we are seeing, we have to find, basically I am not telling you the answer directly, okay. I am just try to think with you, all of you, you will think with me, okay. So how I am going to the solution, okay. So suppose what we have to do, we have to find a subsequence that contain unique character, and that would be the smallest, okay. So first thing what is coming in my mind, ki to choose a subsequent to choose a group of characters, I can either skip any element, okay. So I can choose this, okay. In that way I can choose any character, means there is no foundation of choose that, choose I will choose that, I will not choose that. There is no foundation, but just thing we have to maintain ki after choosing character, the next character would be present after that previous element, okay. So that one thing is coming. But now second thing what we is coming ki we have to choose all unique elements. So what we can do that ki we can find all how many are unique element in this. So if we found how many are the unique elements, so in this we have 4 unique elements. So can we do something like if we have 4 unique element, so either we can go with the first element and take the 4 unique elements. If we do that, then what would happen, like if we choose this B, and after B now I have to take unique element only, okay. So after B, so for unique element what would I maintain? I maintain a set. For answer I would maintain a set, and whatever character I am choosing, inserting in the set, or before inserting in the set, try to find ki this is present in the set or not. If the element is not present in the set, then I would insert in the set, okay. So in this way I can find the I am going to the string, and I would get the set of unique characters. But here is a problem, we are not able to find the lexicographically smallest. So we cannot abruptly find or randomly find any character and put into the set and just checking ki is this present on set or not. So we cannot do like that. So now here the crunch is that ki what now coming in my mind ki we have to identify what character last we have taken. Okay, so if the last character we have taken, suppose I am, I don't know what subsequence I have to choose, I don't know about it. So what I can do, just I would start from the starting of the string. I don't know this would be a first character or not, I don't know, I will choose it. Okay, I will choose it. So now next I will see the next element. Should I choose it? B. Yes, I would choose it. I would choose it because this is a different character that I have taken earlier. So now I have to check कि should I move this character on the position of the last character? Would I able to do that? So if we found कि the present character is less than the last chosen character, okay, so we want कि this character, the present character would come at the place of last chosen character, because this would give the lexicographically smallest. Okay, so should we do that? Now we are allowed to do that. If we do that, then isn't not create any problem. Now the question is that how can we verify that? So definitely if I have chosen some characters in the string, then that are coming in my unique part, in my unique part. Okay, कि I have to choose that character from chosen all element. Okay, so but now I am trying to skip that. So should I skip that? So what we can do that, if this element is present afterwards in the string, afterward in the string, so then I can drop it, then I can drop it by saying that ki at that time I am not choosing this element, last element, I will choose this last element afterwards. Okay, so I would make the first present element as the last element. Okay, so here, so we would not choose C. Basically first we have chosen C, but now we have removed the C from our last element, our string, resultant string. Now the element would be B. Okay, now comes to the next one. Here A, the same goes with the A, कि this A is also smaller than B. Now we would find, can we remove the last element? So to remove, what we have to check, this element is present after in the string or not. So this element is present here, here only, so we can remove that. Okay, now present store this element. Now the next element, so here C. So now we are seeing कि C is greater than A, so there is no benefit to remove the last element. Okay, so insert this C. Now what the next one? Next is D. The same case is with D, because there is no benefit of having D in the starting, because D is greater than C, so D would be present there. Now after, what we have again C, so we have taken the C element here. Okay, so we would not allow this C to enter again, so we would skip this. Okay, now B. Now the main another point is coming, so we have B. Okay, so now we will check, is B smaller than D? Yes, B is smaller than D. So can we remove it? No, because this D is not present furthermore in the string. If we would remove this, then how this D would come? would D would come in my answer? D would not come because it is not present furthermore. Okay, so in this case we would not delete D, we would add B directly. Okay, so suppose now I am modulating this string as if this D is present here. Okay, if this D is present here, so then we are allowed to remove this D. We are allowed to remove this D. Now, so the next thing is that if we are removing this D, then now we would check, is this B come before D? Before D, because I have removed this is removed, now B is here. Now we would check the same thing here. Okay, we would check the same thing here. So until and unless we would not find a character which is less than, which is less than the character, the present character, we would try to find the last character and remove that. If this character is present in further string, we would do that to the end of the, or to the starting of the string. Okay, so I think the approach would be clear to all of you how we can do that. So I am repeating this again, what I am saying here, कि for every element that is coming, we have to check कि this element can be present or can we replace the last element, and there are two conditions to check this. Okay, there are two conditions to check this. If these two conditions has been passed, then we would try, or we would remove this. First we would remove this and place it here. Now check this again with the last element. Would repeat the same thing again and again when the two conditions would meet, or we would reach to the starting of the string. Okay, what are the two conditions? Ki this my new character, if less than, new character is less than the last character, and this last character would present in the starting of the string, sorry, in the end of the string, or present after the current location, present after the current location. Okay, so this is the whole solution. I think that will be clear to all of you. So now I will show you the code, how can we do that. Okay, so the things that we have to maintain in the code, I am telling you all these things, that would be easy for all of you. I am just giving you some code or some pseudocode type thing. Okay, so what we have to maintain here, every time we have to check with the last element, is this element, we have to check the two conditions with the last element. Okay, the last element that we have chosen. Okay, so if this element is we have to remove, then we have to remove this and add this. So for this, what we have to maintain, we have to maintain a stack of characters. Okay, so in the stack we can check the last element or the top element. If it meet the condition, then we would remove the last element and do again and again until the stack size would greater than 0, would remain greater than 0. Okay, so this stack would be needed for iteration. Now another thing what we have to need, we have, and now how these two conditions we meet. So first condition is checking the last element, smaller thing and greater thing, so that we can check easily. Now the second thing we have to check is this last element that we are removing is present furthermore or not. So for this what we have to do, basically we can maintain, there are two things we can do that. So first, the idea is coming in my mind that I have implemented also, but furthermore I had resolved that or take the easy approach. So what the idea is coming, first idea ki we have unique character only 26. Okay, so for all 26 vectors a to z, we can, in the vector, if I talk about C++, we would store vector of vector int. Okay, in this a represent the geo index and z represent the 25 index, or 25 index represent the z and geo represent the a index. And in this vector we would store all the indices of a character, b, c, d or e. Okay, now every time when we have to find, is this b or is this my last character is present after my current position, then how we can check this? We can just by going to that particular vector. Now we would store these elements in the increasing order, in the sorted order. Okay, now we would use what? Upper bound, not lower bound. Upper bound with what? With the current element. If this element, sorry, not the current element, or we would say yes, current element, because we have to now check the with after the current element. If this after current element this element is present, then we would find our condition met. So we would do that with upper bound. Okay, if we would get this upper bound result, then we would easily find, you would easily say कि this element is present. Okay, so this is also one approach, but we would not go with this approach, this is too lengthy. So how can we go? Just we would maintain the frequency of the characters. Okay, see how many times this character is coming. So we would make in vector of 26 size, okay, I'm just, it is not syntax one, I'm just checking you, 26 size, seeing you. Okay, so we would store the frequency of every character in this vec, how many times this character is coming. Okay, so now when we are iterating the main string, then we can remove this frequency. I will explain the code also, just I am giving you some explanation how I have written the code. Okay, so in this way we can maintain the frequency of this every character, and when we are iterating, doing iteration, we would check, we would reduce the frequency if my frequency, the element basically we have to find, is it present or not after the particular current position, then we would just check ki is frequency of this character is greater than 0, then this character would definitely found. Okay, I think that would be clear, because we are, every time when we are coming on that particular character, now we are reducing this frequency of this character. Okay, if this frequency is reducing, now again frequency is greater than 0 particular character, that means this character is present somewhere else afterwards, because before this index, whatever times this element has been come up, we remove that count from this frequency. So we, if we found this frequency greater than 0, then definitely it would be present. So in this way we can do that. Now what another thing we have to check, we have to maintain the uniqueness also. Okay, so for uniqueness what we can do, we can create a set. Okay, we can create a set of character. When we are inserting any element in this stack, then we can insert in this set also. And if the element means if we are inserting in the set stack, then we would insert in the set. If we are removing from the set, then we would remove stack. If we are removing from the stack, then we would remove from the stack set. Okay, and first when we are coming in iteration, means if when we are starting the iteration, then check if this element is present in the set or not. Okay, so in this way we would maintain the uniqueness also. So all the things I think would be clear. The video length is increasing, so let's move into the code part. Small as subsequence, and this is one. Okay, so now what I have did, this is the size of the string frequency. Now the frequency, I have stored this frequency of every element si minus a. You can easily understood it. Now taken one stack and one set. This set is for uniqueness. Okay, now every time when we are coming, just we are reducing the frequency, as I have told you, just to maintain or just to check if this element would be present somewhere in the future that we need in the furthermore in the code. Okay, so now after reducing the frequency, we would check ki this current element that we are on, is this element present in set earlier or not. Okay, if this element is present, then we don't worry for that element, we have to continue from that. Okay, move to the next iteration. Now if stack size is 0, then nothing, no need to worry, just push into the stack and insert this in the set also. Now if the stack size is not empty, then we have to check the stack. If the stack top element is greater than the present element and the frequency of this top element is greater than 0, that means this element, the top element of the stack, is present somewhere after the current position. Okay, so that means we are allowed to remove this last element. So we would erase this top element from the stack and the set also. Okay, now in this way we would remove all the element that we are allowing by this stack. Okay, so now we would push the current element in the set and the stack both. So now up to here we would get our answer, and now just we get all the characters in the stack, but in the stack these elements are in the reverse position when we pop out them. Okay, so we would first pop out all the element from the stack, and our last element of the stack would move to the in the starting of the answer. Okay, and we have to reverse that for getting the correct answer. So we would reverse that. Now it would the answer. Now this is all about this question. I think the problem statement and the whole solution would be clear to all of you. If you find any doubt, then you can reach on the comment section too. So thank you all of you. Bye bye.